A frequency distribution is an organization of raw data in table form using classes and frequencies. When data are collected in original form, they are called raw data. A frequency is the number of values in a specific class of the distribution. Frequency distributions make it easy for us to draw generalizations and conclusions, describe situations, identify important characteristics and patterns, and make inferences about a set of data regardless of its size. When the range of data values is relatively small, a frequency distribution can be constructed using single data values for each class. This type of distribution is called ungrouped frequency distribution. When data are presented in such a way that intervals are constructed for each class, it is called a grouped frequency distribution. Suppose we want to determine the number of COVID-19 cases per barangay in Quezon City, we may refer to the official website of the Quezon City local government. But because the data are not arranged in order, it is difficult to draw any generalizations or even identify characteristics of the data. If the data will be organized as follows, some generalizations can be made. For instance, as of March 21, majority of the barangays in Quezon City have no recorded COVID-19 case. Or, as of March 21, the greatest number of recorded COVID-19 case in a barangay in Quezon City is 3. As of April 14, 44 barangays in Quezon City recorded the following number of COVID-19 recoveries. Construct a frequency distribution for the data. Step 1. Make a table and place the single data values in column 1. Note that the number of recorded COVID-19 recoveries range from 1 to 5. Step 2. Tally the data in column 2. Step 3. Count the tallies and place the total in column 3. By observation, we can say that as of April 14, majority of the 44 barangays have only one recorded patient who recovered from COVID-19. Or, as of April 14, the greatest number of recorded COVID-19 recoveries in any barangay in Quezon City is 5. Consider the grouped frequency distribution of the number of recorded COVID-19 patients in the Philippines as of April 2. In this frequency distribution, the values from 0 to 9 of the first class interval are called class limits. The lower class limit is 0 and it represents the lowest data value that can be included in the class. The upper class limit is 9 and it represents the highest data value that can be included in the class. The numbers in the second column are called class boundaries. These numbers are used to separate the classes so that there are no gaps in the frequency distribution. Take note that the class limits should have the same decimal place as the data, but the class boundaries should be carried out to one decimal place more than the data and end in a 5. The lower class boundary of negative 0.5 was obtained by subtracting 0.5 from 0, and the upper class boundary of 9.5 was obtained by adding 0.5 to 9. The midpoint between the lower class boundary and the upper class boundary, or class limits of a class interval, is called the class mark or class midpoint. The class width for a class in a frequency distribution is found by subtracting the lower class boundary from the upper class boundary. For example, 9.5 minus negative 0.5 equals 10. The cumulative frequency is the frequency of the class plus the total frequency of the preceding classes. The following values represent the number of recorded COVID-19 cases in 138 barangays in Quezon City as of July 1. Construct a frequency distribution and use 8 class intervals. Step 1. Identify the highest and the lowest value in the data. Find the range. This is the difference between the highest and the lowest value in the data. Decide on the number of class intervals. The number of class intervals should be 8 as given in the problem. Determine the class width by dividing the range by the desired number of classes and rounding up. Select a starting point to be the lower class limit. This is usually the lowest value in the data. Add the class width to get the other lower limits. Also find the upper class limits as well as the lower and upper class boundaries. Step 2. Determine the class marks. This is done by getting the average of the class limits or class boundaries. Step 3. Tally the data. This is usually omitted in the final presentation of the frequency distribution. Step 4. Determine the frequencies from the tallies. Then, add the values in the frequency column. Check the total frequency against the total number of data. Step 5. Find the cumulative frequencies. The cumulative frequency of the last interval is 138. This is equal to the total frequency. The information provided by a frequency distribution is easier to grasp if presented graphically. Most people find a visual picture beneficial in comprehending the essential features of a frequency distribution. A histogram is a graphical display of data using bars of different heights. A histogram for ungrouped data is most suitable when we are interested to know the exact values of the frequencies or if we want to identify the datasets with the lowest and highest frequencies. How do we construct a histogram for ungrouped data? Step 1. Make a frequency distribution. Step 2. Identify the scale for the vertical axis and label it. Step 3. Insert a break in the horizontal axis when needed. Step 4. Determine the appropriate scale for the horizontal axis and label it. Step 5. Draw each bar so that the bar is centered on the horizontal label. Step 6. Give your graph a title and make sure to label the axes accordingly. A histogram for group data is most suitable when we want to clearly display a large set of data and when we do not need to know the exact values of the original data. How do we construct a histogram for group data? Step 1. Make a frequency distribution. Step 2. Identify the scale for the vertical axis and label it. Step 3. Insert a break in the horizontal axis when needed. Step 4. Use the class boundaries in the horizontal axis. Step 5. Draw each bar extending from the lower class boundary to the upper class boundary of each class interval. Note that the height of each bar should be equal to the frequency of its corresponding class interval. Step 6. Give your graph a title and make sure to label the axis accordingly.